Today we're going to do day one of multiplying and dividing rational expressions. I would like you to take note of your homework. It's day one listed on your packet. And go ahead and try these 7 warm-up problems. Once you have attempted each of them, then you may rejoin me on the video. So hit pause now. Taking a look at example 1 on your warm-up, when you multiply like bases, both a base of x, you need to add the exponents. So we would get x to the 7th. For number 2, you also have like bases that are being multiplied, so you need to add your exponents. 3 plus 3 gives us y to the 6th power. When you are dividing like bases, as in examples 3 and 4, you need to remember to subtract the exponents, and your solution will remain wherever the largest exponent previously was. So x to the 6th divided by x to the 2nd is going to give you x to the 4th in your numerator. For number 4, you've got y to the 2nd divided by y to the 5th. So the difference between 5 and 2 is y to the 3rd. Your y to the 3rd needs to be in your denominator where the larger exponent previously was. Now on to factoring. So we've got an easy trinomial. Once you ride a tricycle, then you ride a bicycle. So a trinomial factors into 2 binomials. We've got our first term x and x, that gives us our x squared. For our last terms, we want to know what multiplies to give us 8 and combines by adding or subtracting to give us a 2x. So we've got 4 and 2, and we want it to multiply to be a negative 8 and add or subtract to be a negative 2x. So you need a negative 4 and a positive 2. For the next one, you need to look for your GCF first, which you should be doing on every problem. So if you factor out an x, you are left with x minus 5. If you check your work by redistributing x through, you should get what you started with. And for our last warm-up problem, the GCF, the greatest number of x's that you can divide out of both terms would be x to the 3rd. When you divide x to the 3rd out, you are left with x squared minus 9. And you always need to ask yourself if you are truly done factoring, and you are not, because this x squared minus 9 is a difference of 2 squares, otherwise known as dots. Your x cubed still follows you. A difference of 2 squares is going to factor into x and x, that's the square root of the first term, and the square root of the second term would be 3 and 3. You need a plus sign and a minus sign. You have now factored this one completely. It is important you know what a rational expression is. It is a quotient of 2 polynomials. In other words, 2 polynomials being divided. So here are a few examples. 5 over x would be a really simple rational expression. You could have something like 10 over x squared minus 6. You could also have x plus 3 over x minus 7. And if you look below at the first 3 examples, these are all rational expressions as well. So let's take a look at our first example. We need to simplify the following rational expressions, and we need to identify any values of x for which the expression is undefined. For identifying the values of x, you need to look at your factored original problem. So I'm going to say look at original. On number 1, we don't need to factor here, so we can move forward to simplifying once we identify values of x that we cannot have. So x, if you look at your denominator, what can x not be in the denominator? Remember, your denominator can never be 0 because it's not rational to divide by 0. So if x can't be 0, then that would be where your restriction is on this particular one. So whatever makes your denominator a 0. So x cannot be 0. Now we can go ahead and simplify our numerator and denominator. First thing we need to do is divide or simplify 10 over 6. So we can divide a 2 into both of those numbers, which will leave us with a 5 over 3. For your x's, you've got x to the 8th and x to the 4th. When you're dividing like bases, remember you need to subtract the exponents. So you are left with x to the 4th in your numerator. This would be your final answer there, and here's where your function is undefined. On number 2, we need to first factor our expression. So before you identify what x cannot be, factor your numerator and factor your denominator. So looking at the numerator, it is an easy try. We've got x and x. We're thinking what multiplies to give us 2 and combines to give us 1. That would be a 2 and a 1. We would need a negative 1 and a positive 2 in order for it to work out. And our denominator, if we factor our denominator, we've got x and x, again an easy try. We need to think what multiplies to give us 3 and combines to be a positive 2. So you need a positive 3 and a negative 1. So before you cancel anything, go ahead and state where your function is undefined. So looking at your denominator, what makes each part of your denominator 0? So for the x plus 3, what makes that 0? It would be if x equals a negative 3. For x minus 1, what makes that 0? So what would x have to be for blank minus 1 to be 0? That would be a value of 1. So x cannot be negative 3 and x cannot be 1 because that would create an undefined denominator. Now we can move forward with simplifying, so we can go ahead and cancel out any like factors. So we have an x minus 1 on top and we have an x minus 1 on the bottom. That will leave us with our simplified solution of x plus 2 divided by x plus 3. And these are not like factors, so we cannot cancel anything else on this example. I would like you to go ahead and hit pause and attempt number 3. Remember, factor first, then decide where your denominator is undefined, and then simplify. Please rejoin me once you've attempted this problem. So I'm going to go ahead and factor out my GCF of x. That leaves me with a 4 minus x. And in the denominator, my denominator factors into x and x, 4 and 2, and it needs to be a negative 4 and a positive 2. For where the denominator is undefined, x cannot be equal to 4 and x cannot be equal to negative 2 because that is the numbers that would make the denominators 0. So this is what x cannot be. Looking at our problem, ask yourself if there's anything that cancels. 4 minus x on the top and x minus 4 on the bottom look similar, but they're not the same thing. So unfortunately, this is as far as you can go with simplifying this example. Taking a look now at multiplying the rational expressions, you've got a couple of steps you're going to follow. The first thing you need to do is factor everything completely. Then you need to divide out common factors of the numerators and denominators. And by divide out, I mean cancel. So cancel things that are the same, just like we did with simplifying. Then you need to actually multiply the numerators and multiply the denominators by one another. And then you need to make sure that the numerators and denominators do not have anything left in common other than 1. So you may have to simplify again. So let's take a look at our first example here. For our first example, I'm going to simplify each expression. So 3/2 is already simplified. Looking at my x's, those are like bases, so x to the 5th over x to the 3rd would give me an x to the 2nd on top because I'm subtracting the exponents. And for my y's, I'm again subtracting exponents. I am left with a y to the 4th. For my next expression, I need to simplify. Again, 10/9 is already simplified. For my x's, I would be left with an x to the 1st in the numerator once I take 3 minus 2. And for my y's, I'd be left with a y to the 1st in my denominator. Now you're ready to multiply. So you need to multiply straight across the top. So we are going to multiply our numerators times one another, and then we will multiply our denominators times one another. So for our numerators, when you multiply like bases, you have to add the exponents. So 3 times 10 gives you a 30, and x squared times x gives you an x to the 3rd. For your denominators, 2 times 9 gives us 18, and y to the 4th times y to the 1st gives you y to the 5th. The only thing left to simplify on this problem is your numbers. So 30 and 18 can reduce, and 30 and 18 would reduce to be 5 over 3. Because 6 goes into both of those. You still will have your x to the 3rd and your y to the 5th, and that would be fully simplified. You can also cross-reduce in these problems if you want to with multiplication. And what I mean by that is the 3 would simplify with the 9, so the 9 would become a 3, and you can cross-reduce the 2 and the 10. The 2 would become a 1, the 10 would become a 5. So taking a look at number 3 and 4, first you need to simplify each expression, make your life a little bit easier. So I'm going to simplify my first one, x over 15, that's already simple, multiplied by x to the 7th over 2x to the 1st. I can subtract the exponents on those x's, so that would leave me with an x to the 6th in my numerator, and I still will have a 2 in my denominator. And for the 20 divided by x to the 4th, that is also simplified individually. Now, again, you can cross-reduce. So you can reduce anything in any of your numerators with anything in your denominators. So I'm going to reduce some numbers here. I'm going to reduce the 2 and the 20. So 2 would become a 1, the 20 would become a 10. I can even reduce the 10 with the 15 in my denominator. So 5 goes into 15 3 times, and 5 goes into 10 twice. I am now going to multiply all of my numerators. So I need to multiply x times x to the 6th times the 2 in my numerator. That will leave me with a 2x to the 7th when I add those exponents. And in my denominator, I need to multiply a 3 times a 1 times an x to the 4th. So 3x to the 4th. Lastly, I need to combine like terms between the top and bottom. So x to the 7th divided by x to the 4th would leave me 2 over 3 and x to the 3rd in the numerator when you subtract those exponents. For number 4, this is one that you need to factor. So go ahead and factor everything that you can. You can factor out a 10. That leaves you with x minus 4. In the denominator, you've got x and x. You've got 4 and 2, and you need both of those to be negative to give you a negative 6x, and to multiply to be a positive 8. We are multiplying that by x plus 3 divided by 5 times x plus 3. You can now simplify anything in any numerator with the same thing in any denominator. So I'm going to cancel my x plus 3's. I've got one on top, one on bottom. I'm also going to cancel my x minus 4's because I had one on top and one on bottom. And I'm going to cross-reduce the 10 and the 5. So 10 and 5, if I reduce those, would become a 2 and a 1. I can now multiply straight across the top. The only thing I have left on the top is a 2. In the denominator, I've got an x minus 2 left, and I've got a 1 left. So you are left with x minus 2 in the denominator. Now on to some division.